So we're reviewing for the parametrics test, and I gave the guys here a, excuse me, a rectangular equation, and I gave it a limit though, because that makes it a little more challenging. And I said, make it into a parametric. So what does a parametric has? It has an x equation, has a y equation, and it has a t limit. It doesn't have to be t, but we're going to use t. All right, so give this your best shot. Once it's got an x equation and a y equation and a t limit, compare with the kid next to you. I'm going to pause, retry that. So, x equals equation, y equals equation. Well, the y equals is pretty much done. It's 2, but then you replace the x with t plus 6, and then x equals t. That's supposed to be a t. It's kind of a weird way to start a t. There. And then, if x is 0, then t is 0. It's just that simple. X is t, so t is greater than or equal to 0. These get more complicated, but that shouldn't have been too tough. Raise your hand if you had that one right. Okay, good. On to go from parametric to rectangular. Okay, well, here's a parametric. I'm going to definitely step up onto one of the harder kinds of parametrics. Let's say x equals cosine of theta and y equals, let's make it actually 2 cosine of theta and make this 2 sine of theta. And then let's make our theta be, and you might be like, where's the t? Well, t is theta this time. They can do that. It is not required that the letter has to be t, but there has to be a third variable. And I'm going to say it goes from 3 pi over 2 to 2 pi. Now, I hope you know what part of the circle that is. And hopefully by now you've kind of caught on these are always a circle. If you haven't caught on to that, maybe in your TXY chart, when you find 3 points, 2 are given. This tells you the ends, but you got to find one that's in between those two. Find 3 points on this chart and then sketch it. Remember, it's got a direction. Remember, it doesn't go forever, but it's kind of in a circular shape. I'm pausing while you give this one a shot. Let's dig in and see what your points were. Cooper, I trust you. I think you probably got 3 logical points here. You had 3 pi over 2. And 7 pi over 6, did you say, or 7 pi over 4? 7 pi over 4, that totally works. 7 pi over 6 wouldn't have. And then the last one here is 2 pi. All right, good. Now, would you please tell me, this one everybody has, this one everybody has, but you guys might have chosen a different point that was between here and here. All right, but for 3 pi over 2, that's this spot, that's at 0, negative 1. Then what is cosine there? And therefore you multiply it by 2 and you still have 0. Now let's go a little faster. I'm just trying to show people how we'd get those. And then what's the other one? Negative 2 is correct. All right, Cooper, would you read me these last 2 at the bottom? If you use 7 pi over 4, there'd be your point. And the last one?
X would be
2 and 0. All right. Then I'm going to graph this. 0, negative 2. Well, oh my gosh, that kind of looks the same as the picture we have here already. Except that's not 1 anymore. It's down 2. And then the other one is, well, I don't know what these decimals are. Well, you know they're decimals. You should know that they're less than 2. It's being divided by something that is bigger than 1. And this one's negative some decimal. So that's basically over a little bit, down a little bit, and we're not sure exactly how far it is. I wouldn't have been harsh on exactly where that was. And then last but not least is 2, 0, which is like right there. And look at that, it's a curve. And then you need an arrow that goes in that direction. And there it is. Raise your hand if you had that one right. Cool. Now, the square everything deal. Why are we doing this? Well, because we can square everything. And if I'm going to square everything, I got to square the 2 also. You might not know why. It's because 2 cosine theta is going to get squared like this. We just happen to pop it in here, kind of in the middle of the cosine, but the squared also hits the 2. Okay, so that's going to become x squared plus y squared equals 4, and I'm factoring it out. And then what's cosine squared plus sine squared? It's really 1. So that just becomes 4. Because there was going to be a factored out cosine squared plus sine squared, which is 1. All right, is that exactly right, though? No, because that, it'd be the whole circle, and we only have part of the circle. So x squared plus y squared equals 4 was nice try, but how are we going to get it to be limited to just that area? You would have to say x has to stay something and y has to stay something. Who's got those answers? If you think now, I think you can do it. Would you please write a little limit that would keep it? And you can't just do it with x's. If you say, I want x to be bigger than 1, you're going to get this part of the circle too. So you can't just do it with x's. You got to do it with a combo of x's and y's. I'm going to pause for a second while you figure out what those limits would have to be. All right, you had to say that x had to stay greater than or equal to 0 to keep it, that way. And then y had to stay below 0 or equal to 0. Yes?
Can you just do 0 is x and then...
If you're going to put x and y into the same statement, don't. Is that what you were going to do?
I was going to do x and then I was going to do 0 is less than or equal to x less than or equal to 2. Because wouldn't that limit the whole thing?
Okay, so I get what you're saying. You're saying that you want this x to stay between 0 and 2. But the problem with a circle is that it's also got points in there. Do you see how you wouldn't have taken out those points? Your circle would have kept on going, and all of these points would have still been allowed, because if you just said this, it wouldn't have chopped out these points. We want to somehow chop out these points. And how do you do that? By saying that y has to stay less.
And then I added y is -2 less than or equal to 1.
Oh, if you have two limits like
Yeah.
that, sure. But then your limit is overly, like here, let's finish it. You said, oh, I also had this. What's your y between?
-2 and 0.
Okay, -2 and 0. And again, you're not wrong. If you include both of those, I would have said it was okay.
Oh.
But you don't have to say to keep x, just listen, this is important. You don't have to say to keep x less than 2, because if you think about it, x won't go past 2. Like, look at it, it's a circle, and the most it'll go is over 2. Yes?
How do you know if it's a circle again?
Yeah, just because every time we've done these, this is our fourth one, they've always been circles. And here's another way. Once we solved it, see that? That's an equation of a circle.
Okay.
So once you know that this thing's rectangular and it looks like that, that's the equation of a circle. That's how you know it's a circle.
Okay.
All right, let's move on. This page, please. Would you agree that that is a non-parametric? Make it into a parametric and make it so that it stays between -4 and 6. We did something similar to this earlier this hour, but this is also one of the tougher ones, so let's see if you can do it. Okay, the way I think this through is I look at this and I say that is pretty much a y equation. It's just I needed t in there, so I'm going to put a t in instead of x. So t to the third minus 3t plus 8. Then I just said effectively that I'm replacing the x with t, so then x is t. Then, since x wanted to be between this and this, t is x, so we can keep those the same. That's all there is to it. Who had that one right? Cool. You just made a parametric. All right, on to this one. You got to make a parametric again, and this one has a flaw in the problem. Very good. It doesn't say which way this is going. I will tell you it's going that way by putting in a couple of multicolored arrows. It's going that way. All right, I'm going to pause for a second while you figure out the parametric for this. Hey, so we're back. Here's the fast way. If you want x and y to be 4 and 2, then you make x be 4 and y be 2. That's pretty easy. But what about the t? Well, if you have t be between 0 and 1, then when t is 0, it'll just knock out this t here at the end. And why can't I just do it like that? Because the second point wouldn't work. The second point needs to be this, so I need to look and see, I want 4 to turn into 8. So I want that to go up by 4, so then there needs to be a 4 right here. And I need this one to go down 5. So then that's minus 5t. Raise your hand if you had that one right, including that and that. Okay, any questions? All right, how about if we do something different than you've normally done before? X equals 4y minus 7, and I'm going to tell you I only want to do this when y is less than 0. Would you agree that that is not parametric at all? But you could make it parametric. Give it a shot. Okay, so y equals t. That's all there is to it. Just make this be t. Do I have an x equation? Yep. Do I have a y equation? Yep. And then I have to have a limit. So I just make, well, y is t, so y was less than 0, so t must be less than 0. There you go. That's all there is to it. Now, is there another way to do it? Sure. If there's another way, the way you'd have to prove that your way worked is a txy chart. Not saying we need to make one for yours, but if you want to check if your way worked, when you stick in your t as 0 or your whatever you did, it better have a point come out that would be the same thing as you'd get on the original equation. So if you want to check if you're right, you make a txy and make sure that the points you get out of this original one would be the same. Yes?
Out of pure curiosity, stop. When is this, like, what field of work is this used in? Like, why was this created?
So imagine you had to launch a rocket. Would you agree that as your rocket is going up, there's a whole bunch of different variables at the same time? That was a question. You get how that there would be a whole bunch of different variables. What you've learned so far is very simplistic. You've just learned x and y. And now we're adding a third variable. There could be a fourth, a fifth, a sixth, a seventh variable that could all go into something. Because what if there's wind blowing? Isn't that going to affect your rocket? Yep. What if there's actually the spin of the Earth affects even like a bullet being shot? A bullet being shot a long ways, you have to factor in the Coriolis effect, which is the fact that the Earth is spinning while the bullet is going straight. I mean, there's so many things you could factor in the real world. We're just trying to amp it up from 2 variables, which is like time and height, to get a little more complex to throw in a third thing. In this case, it would be usually like distance from like the lateral distance instead of just the height. It's the over distance from you. But you could use the same process of adding in variables to add in a whole bunch of different variables. Okay, so this just allows us to get more complex, which makes it more like the real world. I would not want to be the person who has to figure out exactly which angle should we launch the rocket at so that we can hit Mars. Like there's so many things happening. Spin of the Earth, wind, gotta adjust for, I'm never even gonna get close to naming all of them, but we've just added in one extra variable. Yes?
Then why do we need to transfer from parametric to rectangular?
But this is just about understanding how you could change from one thing to another. We did the same thing last time with polar, right? We took things that were in polar and showed how you could do it in rectangular. So, yeah, it's just about understanding it. It's sort of like saying, why do I have to know how to speak Spanish? Well, maybe you don't. Maybe you could just speak English and have a translator that would translate all your English into Spanish. A lot of people do that. They go to countries like, let's say you're going to Mexico and you have your phone and you can talk into it and do the translation. You can get along with that. But if you really want to be fluent, you want to be able to switch things from one system to another. You know what I mean? There's ways to get by. All right, so it's my job to try to teach you, to understand different ways to think. That's really what I hope you get. School isn't just about what am I going to use next week. It's kind of giving you a challenge on thinking. That's really you're going to have to stretch in the real world. No, you won't use this on a daily basis, but if you can't rise to a challenge like this, which I think you are, but if you can't rise to a challenge like this, that's the biggest thing, is when you are faced with a challenge out in the real world, like, I need to make my business grow. How can I? This is just expanding your ability to think about hard things. Okay, let's go on to, we've already talked about those. Yay, we've covered everything. So this is the part where I want to give you some time to work. There is a worksheet, and just like last time I said, you don't even have to do it. You can do whatever you need to do. This time I don't think that was a great idea. I think the last test was worse than normal. So I'm going to ask that you do the worksheet, but skip any two problems of your choice. If it looks like scary and hard and you don't do it, that's actually not the right way to do it. You should do the ones that scare you because they're on the test. So skip any two problems off the review worksheet. It's actually kind of short. If you look at it, it's not that bad. And you can skip any two. Get it done, drop it in the Dropbox, it counts in the formative, and it's like a double whammy. If you can't do a worksheet where we've given you the key, you're just not trying. All right. And that's all I've got. And we don't give you the key to make your life easy. We give you the key so you can be like, am I doing this right? You need feedback. I remember learning calculus when I had to take this big test to be nationally board certified. I had to go back and be tested on calculus. And if I just had a problem and I did it, you can't tell if you did it right. It's kind of useless unless you know if you did it right. That's why I post the keys. Because if you do it and then you can look and say, yep, I did it right, that's critical to know. And I can't believe that a lot of math teachers don't ever post the answers. It's like, I just don't understand. Because if you can't tell if you're doing it right, like, it doesn't really help to even do it. Okay, so that's just an opinion. I get there are times when kids just straight copying the keys and they get frustrated, but there's got to be other ways around it. We need to help you understand if you're doing it right. And that is all I have for the video for today.